Did you ever wonder how much defects actually cost? If you do, then keep watching. We will calculate the financial benefit of quality-centric improvement projects with focus on non-quality cost, NQC, or cost of poor quality, COPQ. And the method is used for manufacturing and also service operations. It works for any kind of business. And non-quality cost, in essence, is the impact that come from defects, delays, disconnects, deviations, and customer dissatisfactions. The D words. They reduce the bottom line. By how much? Let's calculate. Okay, cost of poor quality. What do we need to know? We need to know the planning yield or the front-end yield. And this means how well we schedule resources and how well those resources are actually available when we need them. So the capacity resource planning. Next, in our value chain is the operating yield, converting inputs into outputs. So this can be manufacturing or this can be delivering a service. And then the fulfillment yield, how happy the customer is with the result. That includes on-time delivery, in-full delivery, and customer is completely happy. That's an ideal case. Then fulfillment yield is 100%. Then we need to know the solving rate. For all the yield losses that we have, how effectively we are solving them. What's the total cost of our business unit, our department, division, or business unit? Yeah. The rework cost, how much it costs to rework if something goes wrong. What is the scrap cost? And by entering those factors in the calculator, we are getting a result. We can simulate this before the improvement and after the improvement. And the delta between the two is the benefit that we could generate. Okay, non-quality cost model and formulas. We need to know several things. The good rate. This is the rolled throughput yield, and that is the product of the three factors. Planning yield multiplied by operating yield multiplied by fulfillment yield. And the rework rate is the opposite of it. So it's 1 minus the good rate multiplied by the solving rate. The scrap rate is whatever is left that could not be reworked is the scrap rate. The rework cost is the rework rate, so the rate of successful rework multiplied by the rework cost. And the scrap cost is the scrap rate multiplied by the scrap cost, whatever cannot be recovered. And the non-quality cost at the end is the total of rework cost plus scrap cost. Let's make an example. Let's say we are running a dentist office and 10% of our patients need to reschedule. Or let's say the doctor is scheduled in a way that we need to reschedule 10% patients because our plan was not that accurate. Or another case, we are planning in our factory for some production, but we don't have all the resources available, so there is a planning yield loss. So we need to replan. What's the replanning rate? Yeah, let's say we are quite good. It's 95%. 1 out of 20 appointments or 1 out of 20 orders we have to reschedule. That's not bad. Operating yield. This is how well we convert inputs into outputs right first time. Let's say we are running something in high tech where the first pass yield, maybe it's quite low, let's say 70%. And the customers at the end, that the fulfillment yield, whatever we send the customer, it's, let's say we are sending 90% out on time in full. And not all customers are happy. So even though it's on time and in full. Maybe they're not quite happy with what they got. So we have 85% fulfillment yield. Out of all these problems, we can solve, we can solve 95%. For 95%. And the total cost in our department is $1 million. It's a small department. And the rework cost is 20%. So if you have a business, or if you have a department, if you have a group, you need to determine how many activities, how many of your people, how many labor hours, how many resource hours are used for rework. In our case, let's say people are quite busy. 40% of the people are busy with rework. That's an extreme example. And the failure cost is, if we cannot repair it and it's completely lost, it's 100%. The failure cost is 100%. But if we are producing something that we can recover partially, for example, in this case, we have 10% material can be reclaimed. Or when we provide a service, we don't have to do the service completely new. There's always a part lost and a part still can be so-called recycled. In this case, we can use 10% of the output we can still use, and 90% is really lost in case of a failure. This would mean the quality improvement potential is at the planning yield, operating yield, and fulfillment yield, we are multiplying these three, we are getting a failure rate of, we're starting with 100, we have 57% that is good, and 43% that is not passing right first time. So 41% of that can be successfully reworked, and 2% is scrap after attempt to rework. That means the rework cost is 165,000. The failure cost, so what we have to throw away, is 19,000. And the sum of the two is 184,000 in non-quality cost. And the non-quality cost accounts for 18% of the total cost of our department. So now it's up to you. Enter your numbers, play with the simulation, and get an idea about how much defects actually cost. And if you need our help, go to the consulting cost reduction program, and we can help you to develop your specific cost reduction program. Or in Academy, cost reduction strategies allows you to get certified, become a certified cost reduction professional. I hope you enjoyed this quick introduction. This was Jörg Münzing from LeanMap. Thanks for watching.